Welcome to the STEM Pathways podcast, where we delve into the fascinating world of science, technology, engineering, and math. I'm your host, Rohan Sharma, a passionate explorer of all things STEM. Each episode, we bring to you captivating stories, cutting edge research, and inspiring interviews with experts and enthusiasts who are pushing the boundaries of innovation. Whether you're a student, a professional, or just curious about how the world works, join us as we unlock the mysteries of the universe and explore the endless possibilities of STEM. Let's get started. Today, I'll be interviewing Jack Challis, who has a Ph.D. from Yale in physics. How are you doing today?
I'm doing great, Rowan. It's a pleasure to talk to you.
Yeah, thank you for joining me. So to start off with, I want to ask what motivated you to get a bachelor's degree in physics and math?
Well, it was seemed like the best idea at the time. I was at the University of Kentucky around 2000, and I'd always enjoyed math, and I took some math and physics courses, and I liked it, and I just kept going. I don't think it was a strategic long-term plan. I just followed the path of least resistance. I liked what I was doing, and I wanted more of it. Maybe one thing that'd be useful for your audience is that I liked the people I saw taking math and physics, and a lot of my educational experience, and I'm sure this is true for a lot of people, is shaped not just by the course material, but the people that surround you and the people that you are engaged with. And I wanted to spend more time with the people I saw taking math and physics classes, and that pulled me in that direction.
Yeah. What made you want to pursue a PhD?
Well, at the time, the only way it made sense to me to be able to keep doing science as I understood it was to get a graduate education. Now, why physics versus math or chemistry, I think is a good question, but I had a really good physics mentor, Gampati Murthy at University of Kentucky, and I really liked his day job. I liked how he spent his time, his combination of research and teaching and working with students. And I thought, well, if I want to do more things like Dr. Murthy, I should probably get a PhD. And I think that made sense at the time for me, because I liked where I was going. I liked the difficulty of the work, and it was very clear that if I wanted to contribute to physics, I was going to have to take graduate studies. So that was the path I was headed on.
Can you talk a little bit about different careers in physics? Obviously, it's like a very wide field.
Sure. So I think one thing that's very important is what you do for your education and what you do for your career are a little divergent. I think most people who study physics like thinking of the world in a quantitative way. They like understanding the simple mechanisms that drive the world. And so I think most people that study physics ultimately want more of those kinds of things. They want to be in quantitative fields. They want to be in areas where you're building simple models of the world, so that helps you understand dynamics and make better predictions. So the main applications of this have been in, of course, academic science, but have also been in engineering, broadly defined, particularly applied physics. There's been most of the work at the interface of light and information technology rewards physics. So you think like communication engineering or photonics, very physics heavy place. And then there's things that don't sound like physics that tend to hire a lot of physics, like investments, where predictive modeling and building a quantitative picture of the world is very reasonable. Computer science is a very common place to go, whether it's software engineering or building tooling. The national laboratories, for instance, Livermore and Sandia and Idaho, hire a lot of physicists to work on problems either that are classified or not classified. And I explored basically all these job things. The one I ended up in that hires probably at least as many physicists as academic science is healthcare. And healthcare generally has a couple of different tracks. One track is for medical physics, which is around helping ensure radiotherapy equipment is safe for patients. So that is, a patient has a cancer and you want to irradiate that cancer. How do I make sure that I'm spending this energy in a way that kills the things I want to kill, but not kill the things I don't want to kill? How do I keep the patient, put most of the dose in the cancer so that I kill the cancer, but don't hurt the healthy tissue and hurt the patient? Medical physics is a very, very clear career path with very clear direct patient impact.
Yeah.
I've also been involved heavily in health information technology, where you build models of patient information and records in order to drive intelligent decision making. All these things are things that physicists have been involved in.
Yeah. Moving back to your PhD for a second, can you talk a little bit about what your research was about?
Sure. So I worked on condensed matter physics. That's a very broad field, but generally it's physics that describes solids and liquids in various states of matter, and it covers many, many details of these. It includes electronic properties, thermal properties, and sound, and many, many, many things. One area of condensed matter physics that was very popular when I was studying my PhD was building ideal model systems. So if you think of a lump of metal, it's got 10 to the 24th molecules in it, interacting in a very complex way. And there is no computer you could build on the planet that would be able to track all those 10 to the 24 different molecules independently. So you have to simplify in very clear ways. And a lot about condensed matter physics is that fundamental problem that the atomic picture of a solid is never going to be tractable as a problem. So there's different ways to build models, and the field is vast enough that you can talk about lots of them, but one that arrived around when I was doing my PhD is you can create a synthetic system which has many of the features of a physical system, but with a lot of the complexity removed. So you make an artificial system that you can understand at some depth to give you some insights into more complex real systems. I was studying a 3D lattice made out of lasers. So you take a laser and you put in three things, and when you look at the interference pattern, it looks like a lattice. And you take atoms that have been chilled to very, very, very low temperatures, so close to absolute zero that they're behaving in a very, very quantum mechanical way. And if you take those lasers and you take those atoms, you can load them into the lattice in a way that looks a little bit like a toy model of a physical solid. You can ask things about how interactions drive things. If the lattice moves, how might those issues drive things? I was interested in introducing non-equilibrium aspects into this. You can think of it like melting. I was interested in melting of this lattice, which can be related to other problems. two practical things that have come out of this, which I'm sure your audience is more interested in. One is using Bose-Einstein condensates as very efficient accelerometers and gravitometers. So you know what a nuclear sub does, goes under the water, hides for 2 months, and comes up only infrequently to establish. One of the biggest limitations on how far a nuclear sub can travel is that the longer it's underwater, the guidance gets further off. This Bose-Einstein condensate would allow it to have a much more accurate geopositioning as you would go, and presumably could extend the length of subtours, as an example. The second application is as a quantum computer. So very briefly, quantum computers encode information in the quantum mechanical state of a complex object. It manipulates that state, and due to certain features of quantum mechanics, the computer outperforms other kinds of classical computers on a range of problems. And you can use this to build a quantum computer as well. So I think those problems, quantum information and precision metrology, were both very popular, very hot when I was studying. And this was very much in the middle of that problem of precision metrology and quantum computing.
Yeah. Can you talk a little bit about what you did at your first job out of your PhD?
Sure. So I did not want to do a postdoc. So there is a common career path for people staying in academic science, which is not the majority, which is to go on and do a postdoc. There's a joke that at the fall picnic, you see 30 new graduate students, 15 new postdocs, 3 new junior faculty, and 1 new tenured faculty, 1 new senior faculty. And what I kind of realized from the fall picnic was, you know, those were riding up a narrowing spiral staircase because the 30 graduate students would become the 15 postdocs, would become the 3 junior faculty, would become the 1 senior faculty. So what happened to the other 29 people along that journey? They went and did something else. And I chose to get off the train at the postdoc stage. So I went and I worked for a subsidiary of Kaiser Permanente here on the West Coast. Kaiser is a combination of a healthcare provider and an insurer, so they're a little bit different than the way most care works, but they're an integrated delivery network. And they had a range of ways to help their patients stay healthy. Because for Kaiser, if you went to the hospital or you got sick, that cost them money. They didn't make any money. So they wanted people healthy. That was their goal. So to keep people healthy, they had things like getting their cholesterol under control, getting their blood pressure under control, et cetera. I helped identify patients in the Kaiser system who would benefit from getting onto these therapies, and as a result, reduce the likelihood that they would have a heart attack or a stroke or develop diabetes, which would, of course, be bad for their health, but also represent a lot of extra cost. So you can think of it as supercharged preventive medicine. And I was involved in building the models that took the data coming out of Kaiser's electronic medical record to optimize who should they be talking to and what should they be talking about.
Yeah. Can you talk about ClinicCast then?
So I wanted to start my own company, which I'm sure many of your audience think about. We were basically a design consultancy. So there are lots of customers in the world with problems everywhere that you go. But for whatever reason, those customers may not have the expertise in-house to solve those problems. So a very common one is health insurers want to reduce their utilization of certain resources, but how do they do it, and how can they use their data to do it? So we built a predictive modeling design shop where if a customer had a problem in a data set, we built a tool to help them. And we did that for lots of use cases. We did it for insurers, we did it for hospitals, we did it for lots of groups where there was a well-defined problem in a well-defined data set, and how can I link the two?
Yeah. Did you like starting your own company?
I did. I think, you know, maybe one thing to feed, you know, to your listeners is, you probably think that if you're going to start a company at some point in your life, you should start it after you've had a big career and learned a lot of things and built a lot of experience and a lot of industry connections, right? Do it at sort of the cherry on the sundae. But the reality is that as you get older, you get a lot more responsibilities. You get, you know, say a mortgage for your house, or you get kids that have costs. And so your tolerance of risk drops as you get older because frankly, you have more to lose. So I think for me, starting the company before I had a family, before I had a mortgage, made a lot of sense and allowed me to take a chance on something that I saw. You know, I think I saw an opportunity that was opening up and I decided to pursue it. And I thought I had a unique offering in the marketplace, and several of our customers agreed with us. So I would say, you know, there's probably several people you know who want to study business, whatever that means. And I have no doubt that there is a lot of value you can learn about business and making good choices and good training, et cetera. But there is no classroom I could have ever had that taught me more about the actual needs of serving a customer than to have my own business where I was actually getting paid for the work. That sharpens your attention very quickly.
Yeah. What made you want to switch from doing that to then working at Elekta?
Very simple. Elekta bought my company.
Oh,
So one of the easiest ways to move over is to have your company be bought. Yeah, you know, we did a lot of work in oncology, and a lot of our customers were Elekta customers, and it was a natural fit. And they made me an offer that I accepted. Very simple.
how many people were part of
I
your
would
company?
say we had about 20, and it fluctuated from time to time. We had about 20, and there was my good friend and I were the principals, and then we had some folks we brought in for different levels of expertise. We also hired quite a large team in Nepal to help us with our work. So, you know, between our team in Nepal and us, it was about 20.
Okay. Yeah. So, how much did your job change after you'd been bought?
Well, a lot. I mean, you go from being the, you know, big fish in a very little pond to the not so big fish in a very, very big pond. And, you know, I went from being, it went from me to the board of directors, who were very skeptical and kept me aligned and kept me at times. You know, even if you're the boss, you still have a boss. Where I went to where I had a boss, and he had a boss, he had a boss, he reported to the chief of directors. So, you know, you're in a pyramid. That means your scope is much more defined. I had a budget, I had a mandate. So maybe the breadth dropped a lot, but in depth, I suddenly went from one customer to hundreds of customers, which is a different experience. I had to think a lot about standardizing our processes so that we can meet their needs. You know, in such a large organization, you have to be very effective working as a team member. And I think that experience taught me a lot about being a team member. It was a good experience. I was very lucky at Elekta that there were a lot of staff that guided me and mentored me and helped me make better choices and work within a multinational. And I really value my time there.
Yeah. So where do you work now?
I work at Lucent. So in 2018, I was the first U.S. hire for a biotech company. I was aware of them for some time. They had started in Singapore as a biotechnology company focused on cancer diagnostics. It was, well, right in the middle of my wheelhouse. It was focused on product development in cancer diagnostics, taking something from sort of bench idea to reality. And I like startups. I think I do my best work in small teams. So I think that was very appealing to me to get to work in a small team.
Yeah. So to end this off, I wanted to ask what advice you'd have for someone who's still in high school wanting to go on your career path.
Well, I want to start with, it's a lot easier to give advice than take it. I want to start with that. So you're going to hear a lot of people say a lot of stuff, but just remember, talk is cheap, work is hard. So, you know, I think one definite thing I would do again is make sure that you read pretty broadly. One. Your parents love you very much. And you have to understand that a lot of their viewpoint comes from a position of love. However, they were your age a long time ago, and things have changed. And they may not be as aware of how things have changed. So there's this famous phrase, fighting the last war. Are you familiar with that? The idea that that even when technology changes, people remember what was hard the last time, and so they work for what was hard the last time, even if that's not what's hard. And there's a famous example of this in France. In France in World War I, they had these difficult trench battles. It was really, really hard. So they built the Maginot Line, this massive defensive boundary around France that was supposed to defend them from future wars, because that was what was hard in World War I. But in the middle time, they developed aircraft and radio and a bunch of other technologies that made that just totally obsolete. And they invested so much in that old war, fighting that old war, that the Germans conquered all of France in 6 weeks in 1940. And the reason is they just went around, right? And they used modern tooling like the Blitzkrieg and Airforce to completely neutralize that. Your parents are a little bit like the Maginot Line. They're worried that you're going to want a stable career or become a doctor or something low risk, because they don't want to see you fail. They don't want to see you struggle. What I want to tell you is that sounds like a low risk option, what they're saying, but it might actually be the higher risk option than, for instance, learning how to build your own business, learning how to serve a customer. And that doesn't have to necessarily be a high-tech startup. I mean, that can be food delivery, but someone who understands how to serve a customer, how to meet their needs, how to solve their pain point, that person will always have a job. Always. There will always be a pain point, and someone with more money than time and interest to solve it that is willing to spend to solve that pain point. That may not be true for becoming a lawyer or a physician or something where the dynamics of the industry means that it's not as bright a future as you might think. So I guess what I would say to someone your age is seek broadly, but if you're worried about your career, which is a fine thing to worry about, focus on what are the problems other people have that they're willing to spend money to fix, and how can you be the person that is going to be that? There's an expression, people don't buy vitamins, people buy painkillers. And the idea is that there's lots of stuff in the world that sounds like it's nice and good and fluffy and good, but ultimately it's only when something hurts that most people are motivated to take the effort to step. You want to be the painkiller. You want to be that, when somebody has a problem and, they can't solve it, you're going to step in and take that away from them. If you can be a painkiller, you have nothing to worry about in your career.
Yeah. All right, then. Thank you for meeting with me.
All right, all the best, Rowan. I hope all the very best, and hope to hear great things from you.
Thank you.